My name is Ofer, and I have John here who will be presenting together with me. And we're going to take the next 35, 40 minutes and talk about solutions that we built with the RouterOS API that are geared toward reducing tech support calls to the minimum and increasing ARPU. Sounds like a futuristic thing, but we could do that. So a quick background, because I know that there's got to be put in context. You can't really see. There we go. So we started a wireless ISP in Napa in 2004. And like many of you in the room, we started it in the same circumstances. You move to the countryside, there's no internet. You hook up a T1. I see people smiling, so I can tell who did exactly that. And figure out what could you do with a T1, too much bandwidth, and you start sharing it with the neighbors. And one thing leads to another, and all of a sudden you have a wireless ISP. And that's exactly what happened with Valley Internet. A decade later, we grew from a little hobby project, we grew to cover 4 counties in California. Right now, about 2,000 square miles from Benicia all the way to Hopland in the north of Lake County. And the other thing that we were successful in doing is really grow our ARPU. And we didn't grow the ARPU just by jacking up prices, but also by introducing additional services, managed network, security cameras, lots of different things. I do have to say that servicing the Napa wineries does give us an advantage on the ARPU, so it kind of pushes it. So we do have customers that pay $18. But there's also customers that pay $700. So between the two of them, the two groups, the ARPU grew well. Somewhere around 2012, right about when Netflix became mainstream, things started to not be as rosy, although this is rosy, but they started to be not as fun as they used to be in the beginning of the project. And primarily, we noticed a few things. One, utilization went through the roof. And again, I know all of you know that, but during peak hours, all of a sudden, users were using everything that we were giving them. So if they were given 8 megabit, it was 8 megabit for the entire neighborhood, the whole evening. That concept of oversubscription got thrown out the door. No more oversubscription. That just didn't make any sense anymore. The second thing that we notice is obviously the home that used to have 1 device, 2 devices, turned to be 7 devices, 20 devices. Today, it's not uncommon for us to call a regular 1,500 square foot home with 40 devices. Of course, they'll say, we don't have that many devices on the network. Right? Yes, you do. Yes, you do. All of this led to a significant erosion in customer happiness. Looking at our help desk, we did a pretty good analysis over the last 3 years. 25% of our calls became chronic, became problematic, they became stretchy, if you will. They last for a week long of callbacks, and mostly my network is slow, or what's hogging my network, and stuff like that. Initially, we thought maybe the problem was just with us, but as we started talking to our friends and neighbor WISPs and other networks, we realized this is not limited to us. And in fact, when we started to look into this project, we studied, there's a Cisco Broadband Utilization report, which I urge you to read. And that was published last year. And it actually said that the problem is bigger than even what we had on the network. They're saying that 38% of US households call their ISP once a month to complain about a chronic issue. Worse, that call is usually never resolved, or, as I quote, resolves itself by itself, which technically means, the download probably stopped, or some update, or somebody rebooted the router, and then they call again the next month with a similar problem, and it just keeps going, and it's eroding, and it's, creating a problem. The things that drive those support calls are, as you know, streaming, cloud services that take up the upload, and it's very difficult to explain customers why when your upload is saturated, your download is not going to be as fast, but can't turn everybody to a TCP engineer. Gaming, latency, jitter, and recently we've been getting more and more calls and emails. How do I curb my teenagers? Other than, shooting them, it's not legal. What do I do? What do I do to get them to stop Instagram, to stop doing everything that they do pretty much, and that's it. I mean, I actually got two things for you, so I don't know if you're going to hear it. So this is a classic my network is slow call from one of our customers. I hope you can hear it.
My computer has returned after very extensive and expensive adjustments, and I explained to the repair people precisely what I was told by Valley Internet, that Microsoft was sucking all my power the instant I got on. Apparently that is still the case, even though I have had everything Microsoft eliminated or quelled in this computer. Please give me a status report on what time I went on and at what time Microsoft started sucking everything away from me.
I couldn't even make it up. This is like as good as it gets. In all honesty, and I hope he won't ever watch this online, I don't think that our solution is going to help this guy, but this is very typical. People don't know what's happening. Here's an email that we recently got. I would like to speak with someone about the simplest way to control Wi-Fi access at my home. I would like the flexibility to limit Wi-Fi, example, my kids' smartphone, Netflix, Hulu usage, and what they do whenever I want. I prefer not to have to change the Wi-Fi code a lot or go through onerous process each time. So this is repeating theme. This is happening now at our network, at every network, and the total sum result of this great adoption of internet is resulting in a very lengthy support call, on average 45 minutes, which gets distributed sometimes to 6 calls, right? So it's 5 minutes here, 10 minutes there, another 5 minutes. Sometimes it's, and 45 minutes average means that there are calls that are 2-3 hours out there. And we also have seen, going from literally 0 churn rate. I mean, other people that were moving, they're the only people that canceled service temporarily, but moving from 0 churn rate, we actually have people that got so frustrated with their network, but with us inability to support them, that they switched from, 20 megabit connection with, 50 millisecond latency to a satellite, because they were just so upset with us. Mind you, yes, they come back when their contract is over, but that's not good. That's not good for business. It's not good for anything. So we set up a goal to improve the support call and close the door, basically, make sure that customers don't leave us. We wanted to change the conversation. We wanted to change the conversation from a confrontation, like, no, you telling me that Microsoft is sucking up my bandwidth. No, that's not true. Nothing is here. Well, did your son just come back from college and stuff like this? From a confrontation to a partnership. We wanted to create something that is more, has more insight, something that is more intelligent. And at the same time, we want to use the resources, the very limited resources that we have, to do other things and not just tech support chronic calls all the time. So one way, obviously, is to throw more people at the problem. The problem is that one agent to 1,500 customer industry standard, okay, that's for AT&T, that's for Comcast, which, by the way, John and I heard a quote that the CIO of Comcast told someone, they're killing us, referring to customer service. So even the big boys are having problem, let alone folks like us. What this graph just basically shows you, that it's practically impossible for us, small wireless ISPs, small ISPs, to hire enough support to meet the standard until we get to a threshold of 15, 20, 30,000 customers. So throwing more people at it is not really a great solution. The other solution that we thought about is turning everybody to be MTCNA certified. That would keep Amin here really, really busy, and we'll get a very intelligent conversation. Nobody will call, and that will be great. In fact, as kind of ludicrous as it sounds, this is how we got to our solution. We said, well, what if there was a way to turn the Winbox to a super, super friendly app? But not just another Winbox that runs on iPhone, but something that can connect with the average user. Something that takes all those tools that we use to troubleshoot, those tools that that Douglas guy, we use those tools. Everybody in this room here uses tools to troubleshoot, network. Traceroute, ping, torching, interface utilization. So we use this all the time, but what if we could take these tools and put them in the palm of the hand of users, but in a friendly way, so friendly that, as we say in the industry, even my mom could use, right? So, and that's what we did. We designed a whole set of new functionality that is consumer friendly, that doesn't talk TCP, that doesn't talk ports, that doesn't talk IPs, and we developed a full solution that connects with the router using the RouterOS API, and we'll talk about that after the demo. Except that because of certain things like the power capability of the iPhone, the power capability of the router, we also introduce a cloud component. And the cloud component makes a huge difference for our solution because it allows us to load balance our solution geographically. It allows us to process traffic information that is otherwise encrypted and we can't see it maybe on our, on the network. And of course, it gives ISPs a way to do administration. And we have solutions that you can deploy, like those smart cloud, smart server inside your network. So to jump to the demo, I'm going to show you everything that I just talked about, how do we approach this. And then after I finish, John will talk specifically on how we turn the API into, okay, so 1 second. How we turn the API into a solution. So let me pick up the reflector so that you could see my iPhone. John, if you don't mind, can you connect to this router with your iPhone and your computer? Of course, the reflector doesn't work. Just 1 second. There we go. That's my iPhone in real life. Now you can see that I use Duolingo. You can see that I track where my kids go with friends and everything. So in a typical way, I would log into a router to see what John is doing, and I would use Winbox, and I would tell him, John, Apple is now pushing you a piece of software, and that's why everything is slow. But what if we could let him, or the user, do everything on their own? This router here is a default setting router with a couple modifications because you're all experts here, so I'll just tell you what I changed here so you know. One is I created a WAN interface on the LTE because I didn't know what connectivity we're going to have here. I secured the password for the wireless so that none of you just try to hack it and all of a sudden take the network down, I also put a password on the router itself. And I think there's one firewall rule. Otherwise, everything else is just defaulted. So what I'm going to do first is I'm going to make this router smart. In order to make this router smart, I'm going to come to our dashboard. This is our lab dashboard. And I'm going to click on the utilities. And I'm going to give, this is difficult. They didn't tell me I'm going to need to do this. Here. I'm going to give the access information. The check status button just allows me to see if the router is reachable. And so right now the cloud is checking this and saying it is reachable. And now I'm going to turn the router to become smart. So that takes like a couple minutes, or I mean a couple seconds. And the router is smart now. Once the router is smart, I can go back to the iPhone. So I'm going to launch the Smart app. So it recognizes that this is not set up right now. So I'm going to begin setup. I'm going to scan the barcode of the router. I'm going to finish setting it up. So it's going to ask me to name the network. I'm just going to call it Denver. And what's my email? Now everybody in the world can know that I have such a short email. I'm going to give it a very smart password. And the first time I log into the router, it's going to learn the network. It's going to try to understand where it is in the globe. It's going to try to test the MTU, the ping, the latency, the speed, so that when I start using this tool, it would already know things about the network and about the router that that are necessary for this configuration. Once this is done, I am at the home page of our application. I can send you screenshots if you want. So you don't have to take selfies. Okay, so what do we have here? At the very top, we have a utilization bar that just shows you how much of the download and how much of the upload is. The network name, you have the utilization month to date. This is very important for some ISPs or some deployments where the user want to track how much they use from the beginning of the month, gigabytes, so they know where they are if there's any limit on the network. The network health is a composite of several indexes that we test, including MTU, including latency, including ping time, including peak utilization, all sorts of things like that. And then if the network is sick, then it will show you that it's sick. But right now, it's really liking it here. You have the top user and some unidentified devices on the network. You can click the button here and it's going to show you. So I could see that there is my MacBook, my iPhone, John's MacBook, and I could start organizing the network. So for example, I can, let's actually do some Netflixing. This is a very fun project to work on because you get to Netflix all the time. Anytime somebody from the company calls me and there's a movie in the background, oh, I'm just testing. I'm going to put the... We don't need the audio for that. Okay, so back here, you could see that my MacBook is using Netflix. And not only I can see services underneath my device, I can actually take Netflix here and change it to standard definition. So instead of telling users, hey, we're going to change your Netflix to only 1 megabit, and it's like, what is 1 megabit? We're just going to do this on your behalf, or you could do it yourself. And now Netflix is just going to take a whole lot less. It's going to drop unless there's a new user. And then it will expire. That shaping that we did, which is basically part of the Q tree, is going to expire in 60 minutes because that's what we set it up to. But looking at the devices like that is not so interesting. One of the things that we could do here is assign devices to identities. So I can say, I can click on this device and notice that the first time I click on it, it asks me who is using this device. I'm going to take the Netflix away because I think you guys are watching the Minions and not me. I can tell like that phone is in the way. There we go. I'll just stop it. So I'm going to create a new identity. I'm going to call it Ofer. That's me. And then I'm going to, oh God, you guys are going to see my photos now. Make sure. Got really good photos here. There we go. And from this point on, I am a user, an identity, and I can add other devices to that identity. Let's do another one with John here. So John is not me, so I'm going to add another identity. John, this is your favorite part. This is John. There we go. John is so pretty. And so now we have John also as an identity. And this is helpful when you have a household, and I have 2 daughters, and 2 teens, I should disclaim. And this allows me to see who's doing what, but it's also useful because I can go to an identity and I could set notifications. So I can, for example, say, tell me when this user is doing social media at night, and I can link this to their contact so that their notification would either come through the app to me or in SMS to them. So if you think, why would I want the notification to go to them? That was a request from my daughter. So she's been on this network for a long time, and I turned into Big Brother for her, and she's like really not happy with Smart Network. I mean, she really started to hate it. Like people would go like, how do you like Smart Network? I hate it. And so I sat down with her and we talked about it and what she asked, and we implemented it, and says, why don't you tell me when I'm violating? When I am watching Netflix or doing social media, or after hours or during bedtime, send me the message, give me 10 minutes. I said, how about 2 minutes? Give me 2 minutes to get off social media before you get the alert. And I thought that was pretty good. It changed. Yes, you can in Smart Network. I can go and I could do block devices. But I can tell you, being a parent, blocking the internet for people, and I see a lot of people nodding their head, is not a solution. Not to mention they switch to LTE, and then your bill just goes through the roof. They find other ways, and Carmel, my daughter, she needs her computer and devices for schoolwork. So I can't really block her device. So this has changed the conversation. She knows I know. She knows she's getting notifications. It has changed the conversation in the house. It has changed the way we communicate with customers. Some of our customers that are on the beta could see what's happening. The conversation literally changed from, you guys suck, to, oh, whoa, I'm using that much. What's the next tier plan? That is a much better conversation to have with a customer than to argue with them that Microsoft is sucking up their network. So, and we're really happy about that. One of the things I wanted to show you, so let's just log into our, I can switch to a different network. I want to give John the stage here soon. I don't have the serial number for my home router. So I printed it. We're working on a version that will allow me to switch it in the app, but right now I just have to scan the home router. So I'm going to scan it. Now this router was already set up, so it's going to ask me just for the password that I gave it before, because I don't have to, reconfigure it. Oop. It's working. I wonder if Carmel changed the password. That's probably what happened here. Okay. Someone's busted. And with that in mind, I'm going to go and give John the slides, and then we do have time for questions after this presentation. So John. And I'll take the time to look at who changed the password.
Thanks, Ofer. So are there any software engineers in here, or is everyone pretty much network focused? Okay, cool. So I'm not a network engineer. I'm a software guy. I've been writing code and building big platforms and systems for 25 years now. And so when I come to this networking world, it's hard for me because I come from a software world where you all network engineers live on that ragged edge of where analog becomes digital and digital becomes analog. Software engineers don't live there. For us, everything's virtual. And that means we have to adapt a lot of things to work in this sort of world. And so one of the most exciting things for me as a software engineer in my team is that what RouterOS gives us is what we call the programmable network, right? Because the API has full feature parity with the CLI and with SSH and with Winbox, which is based on those, anything the network engineers can do in the platform, we can do also. And that really doesn't exist anywhere else. Like people really take it for granted in this room that you can do all these cool things. But if you go to another platform, you don't have access to all that functionality like you do in RouterOS. So for us to be able to do that means our application engineers can live in their little box, our database guys can live in their little box, our app engineers can live in their little box, our network engineers can live in their very large box. And everyone can work together in peace and harmony and not be stepping on each other's toes. And the app engineer doesn't have to worry about what Amin needs him to do, at a network level with the firewall. Amin can just say, here's your API command, execute this against the network. It's going to do what you think it's going to do. And it makes a huge difference for productivity and what we can actually accomplish. We couldn't do the things we could do without the API. And I'll show you in a second, because the other tools like SSH and the CLI and Winbox are built for human consumption, not machine consumption. And what the API has done is made all of those tools machine readable. And let me just give you kind of a quick example of that. Let's see, there we go. So we're all familiar with this, right? This is the interface list. For a human, you look at this and you're like, hey, this is great. I can see everything. I can see all the networks. There's comments. It tells me what's going on. I see MAC addresses. I have a full view of what my network interfaces look like and how they operate. But let me show you how a machine sees it or how a software engineer sees it. We say, hey, these lines aren't the same. Why is this one different? What does the semicolon mean? Is the thing after the semicolon important? What does WAN mean? Why is WAN here? And we say things like, why aren't they all the same? Why is every line different? What's going on? This is very confusing for me because I'm just a software engineer. But what the API gives us is something really, really ugly, which you see up in the right-hand corner. And for a software engineer, we look at that and we go like, oh, thank God, I can parse this. This is incredible. It's, it's very clear. It's key value pairs. It's not redundant. There's no human nonsense in this. There's no subtlety. It's just very straightforward. So not only can the software developers understand this, but the computers can understand it, right? So when we're writing automated systems, they can read this data and deal with it without having to worry about any other subtlety that may have been injected into the system. So we can look at another example here. I think that's a little more illustrative about the difference between API access and SSH access, and that's when we're torching. So everyone here is familiar with Torch, I assume. We all use it every day. And it's awesome, right? You watch the Torch. It shows you in real time what's happening on your network. It tells you things like who's using it, how much they're using. It tells you if it's BPS or KBPS. And so you really get this like at-a-glance view. And there's a problem with it, though, which is that it's what's called stream-based data. So there's a reason this is updating every second. It's because it's rewriting that content and it's pushing it out to you. And having written the code to parse this in real time, I can tell you it sucks. And it's really, really hard to do right. Because you're having to, on every single update, rewrite your entire data set, remember what was there before, recalculate all your results. And the data is not even normalized, right? So if you see it's going between BPPS and KBPPS. And so what that means is on every single iteration, I have to find those. I have to break the number from the letters. I have to take, okay, KBPS, I have to do multiplication, I then have to add that to the previous results, and on and on and on. And so you can see for software, doing that becomes really difficult. But with the API, I just, once again, get my really happy key value pairs, right? It's really simple. And it's, guess what? It's normalized. So I'm not dealing with how the human wants to see the data, which is converted to orders of magnitude. I just get bits. I don't care. I'm a computer. I just want ones and zeros. I just want bits. I don't want any context to the data. And so the API gives us that structured data that systems need. So we don't have to parse all this stuff. We just get the unambiguous output that we can push forward in a really normalized way into our system. And the bonus to this is that because the API is ubiquitous, every major language has libraries for it now, right? So we use the Node libraries in our system. We use the Java libraries at Valley Internet for some of our back office stuff. I think there's a Perl library, there's Python libraries. So pretty much like any language a developer wants to use, they can access the router. And so what this means, and the most important thing for us, is that for the first time, the network becomes a computing accessory, right? Like we can write code for the network now, like we write code for your Fitbit or your Apple Watch or your Nest thermostat or anything else you'd put on your network or connect to your computer or your phone. The network finally has that, and it just didn't have that until RouterOS showed up. There's other platforms that have APIs, but they're not as clean, they don't have feature parity, and they're just really difficult to deal with because they're so special case, right? Like you may have to use only C or only C# or only Java. We can use anything now to work with the network. So with that in mind, I just want to give a couple quick examples of like what we're using, some simple examples of how we're using the API that like from a software perspective or even a network engineering perspective, you may be able to use. Some of them are pretty basic, but they're things we see over and over again people not doing. So we wanted to share them and say, hey, you should think about doing these things. The first one is when you're connecting your systems either in an automated way or a manual way, what we see over and over again and just causes huge problems is people don't clean up after themselves, right? So what happens is as you're working with software in the field, you may like want to do something like create a simple queue, right? And I want to throw a queue. I only want my kid to have a megabit of access, but I don't want that to be forever. So now I have to remember to come and log in and remove that rule later so that my son's not mad that his Netflix is slow. But one of the cool things is in RouterOS, you can put in schedulers, right? So I can schedule a script to remove this rule at a later date. People do that all the time, but what we see is they never remove the schedule or the script, and they never run again, but they're sitting on the router. So then when I come back 3 months later, I see the scheduler, I see a script, and I'm like, wait, what is this thing? Like, is this important now? Is somebody using this? Was Ofer logging into my router and needs this thing? No, he didn't. I just didn't clean up after myself. So all of our systems, and we encourage you to think this way also, put in what we call self-destruct. So when we schedule something to remove this temporary action, we also schedule it to remove itself. It's super basic, but nobody really does this. And so you end up with routers with just tons of cruft on them that cause problems later, because if you don't remove something right, if you leave something behind, if you don't clean up after yourself, it's going to create ripple effects in your system, both from a software perspective and a support perspective, right? So if a support engineer comes in later, he doesn't know what's true or what's not. He just starts deleting stuff. You know, he's like, I don't know, this isn't important. It might be. Wouldn't it be great if everything on the router was always important? That'd be kind of cool. So that's really important. And where it becomes super important is with automated systems, because software needs a constant bedrock to roll on. It can't have the systems changing underneath it. So if you're going to build a software product that scales, you've got to keep it clean. And so what we found is that by doing this, it's let us scale to thousands and thousands of routers and be able to manipulate them in highly automated ways and just never break things. Because at the end of the day, what do you do when you mess this up? You get a support call. You break your network. And so by keeping it clean, you bypass that. So it's a basic thing, but I really want to put that in sort of your minds as something to keep in mind as you start using things like the API. Another thing that you see a lot, and you see this on the forums, and we saw it a lot too, is this idea of randomizing user logins to the router, right? So unfortunately, and we've all seen it, I'm sure nobody here does this. People use like master passwords for like 10 routers or a lot of routers, or they tend to have a password algorithm and they say, oh, I add these 4 digits to the back of the month I installed the router and that's the password for that router. I mean, it's horrible practice, but we all know, obviously no one here does that, but we all know people in the real world do. So that, that idea of having one key or a few keys for everything is a huge security issue in 2017, right? Nobody here would deploy that because we know we're going to get hacked immediately and there's going to be huge problems and huge price to pay later on. This becomes a huge problem at scale. So when you're managing thousands and thousands of routers and you have to be able to log into those routers in an automated way, you really need a better way of managing logins. And so what people tend to do is to do something like create a spreadsheet of passwords. And every time you install a router, you give it a unique username and password, and you type it into the spreadsheet, and you email it around or stick it on a drive somewhere in the cloud. And anytime someone wants to log in, they download the spreadsheet and they log in. Or maybe you are smarter than that and you push it all up into a MySQL database or something, and then all of your automated systems connect to it and read that data. And that's really cool until you want to change something. Right? And now you have to, all of a sudden you need to update, let's say, 1,000 routers login information. So you have to go into the spreadsheet, log into each router, change the password, or write some clever code to do it for you from the server. We kind of decided to do it a little bit different for us. And so what we did is we use a randomization algorithm on the router. And it's a pretty simple algorithm. But what it does is it, on the fly, creates a random username and a random password. Creates a user with the limited access that user needs for our services, and pushes that up to our identity server automatically. And this happens at different intervals. So it may happen hourly, it may happen every 15 minutes. It happens on certain events in our system. So when a VPN connects or disconnects or something like that happens, new credentials are pushed up to the server. And all the API calls now use those credentials automatically to connect back in. So what that means is our entire network of thousands and thousands of routers is cycling its passwords, its credentials automatically, on 15, 30, 60-minute increments. We don't even know what those passwords are, and we don't need to know, and we don't want to know. We don't care. These passwords are for our servers to use, not for us to use. And so just, for people who are kind of into this stuff, what we do is we create a dictionary of allowable letters. And there's many ways to do this. This is just our kind of way. And I want to be clear, this is not a randomized password algorithm. It's like an obfuscated password algorithm that's hard, that you can't really guess, because there's no random functionality in RouterOS right now. And you could call out to a cloud service and get a password or something, but because we're running at such scale, everything needed to be local to the router. We couldn't we don't want to have to depend on a third-party service to generate these logins. So we keep everything local. And what we do is we create this sort of dictionary of allowable content. And then for us, what we do is we go through all the current interfaces that are active. And for every one of those interfaces, we pull a piece of data off them, and we manipulate that to get the right index length, and then we pull a character out of that dictionary. And so what happens is, based on what traffic the network is processing, that determines what the password looks like. And since you can't predict what network the traffic is processing, both on a packet and a byte level, it gives us pretty much random passwords that no one's going to be able to guess, unless they can really control every single interface of that router, both at a byte and a packet level, which just isn't going to happen. So that gives us a lot of control over it. So you kind of see we just sort of iterate through the interfaces. And in this example, we say, hey, if this interface has transmit packets, pull that number off, grab that character from the array, and move on. And so at the end of this, we end up with a 10-character username and a 10-character password by this sort of simple call. And we can now push that into RouterOS, and then we can push that up into the cloud, and now all of our systems automatically use that. What's really great about this is when your systems are inevitably hacked, you have a kill switch, right? In our systems, we have the ability to push a single button and have all the routers, all thousands of our routers, automatically re-register with new login information. Beyond that, these are refreshing themselves on 15, 30-minute increments. So even if someone does get one of these logins, it's invalid in 30 minutes. It's invalid in 15 minutes. And so this creates this rotational security that you're not going to get if you're trying to manage this stuff by hand. So I guess I'm trying to sort of say is, you shouldn't be managing passwords by hand. You don't need to. And if you're going to build a solution using the API that you need to scale past like 5 devices, you need to be thinking in these ways. And you need to be thinking about rotational password security and fully automating it and not passing around spreadsheets or giving people database logins. You should never know your login routers for your automated systems. They should only know that data. And if anybody wants this code, just email mum@spartan.network. I'll send it to you. There's nothing super secret in it, but it could be really helpful for you. And so those are kind of two of the sort of things that we find, those are two API level things and two ideas about using the API that we just see people not do ever, almost. And so we wanted to share those with you and say, hey, if you're thinking about scaling, if you're thinking about automated access and systems level access for server applications to talk to your routers, this is important stuff that you need to be thinking about. For Smart Network as a whole, we're launched to WISPs now. Obviously, we're launched internally. We're launching externally. In Q4, we're going to be launching to consumers out in the market. And when we do that, you'll be able to buy a router from us. But we're also going to let you bring your own router. So our platform lays across, like Ofer showed you, any MikroTik device out there, from the smallest to the largest. We're going to be adding really cool mesh features, so consumers can configure their own mesh in their house, which we see as a big problem. And we're also going to be releasing our Android client in Q4. We know that's really important. And then going into next year, we're going to be adding internationalization because we know there's a lot of ISPs in Europe that need our help. And then moving into things like TR69 for more advanced configurations. And then what I'm most excited about is out in 2019 is releasing a public API so that people can use RouterOS, our service classification engine, our security tools to build their own applications and start to build a platform on top of RouterOS that makes it easier for everyone here to build cool applications because we've just gotten so much benefit from it and we want to help other people do that also. So that's kind of our roadmap going forward. And I think that's about it. That's all I have.
I got into the home network. And there's a lot of Instagram going on right now, but it's their day off, I guess. I don't know. They don't have school today. So open for questions. We did throw some questions on the screen in case you were wondering. The ROI is really in development. This is just an estimate. I'm not able to stand here and tell you that these numbers are solid. We looked at about 9,800 support calls and then subtracted from it the chronic calls, which is the 2,300 that you see there, analyzed them, looked at those customers that got Smart Network deployed, and try to evaluate how much time we're saving with them. The other thing that we are seeing is that about 1 in 4 customers that told us that they're going to cancel, we were able to turn them around by exposing to them what they're doing on their network and really change the conversation. I think we could do better in the future. Capacity right now, we're looking to add, so 1,000 are being deployed in Valley Internet. If there are ISPs, wireless ISPs that would like to join, we're looking for another 4,000 for this round to deploy. And as far as how do we do it, we're actually going to put a router in your network. That router is not a proxy. That router is not Quilt. It's not peer up. It's not a caching. It just sits there, and using the RouterOS API tells the story of what happens, but it doesn't interfere in the network. Any other questions?
So usually your home router is behind the firewall. So if I try to do it manually, you have to have a log in the static IP, and then look at what's activity that connect to the router, like your daughter's device and everything. So sounds like right now, use the API, you can go through the network and see what she's doing. You're not in the same subnet with her right now.
Do you want to answer that?
Yeah, so how do you do that?
So I'm not sure if you're talking about a double NAT situation or just a regular firewall, but it doesn't really matter to us because we establish a tunnel.
Okay.
And so the RouterOS API communication is happening on a tunnel. So the communication is coming from within the network to us, and then we're able to take the reports from the router and turn them into a visualized presentation to the end user.
So what happened? I have a router, like you say, I have a password defined it. How can you tunnel into my router that way? So you bypass the password?
No. So
Okay.
if you are setting up a brand new smart router,
Right.
you can use the app to initiate the tunnel. You are the only one that's going to know your username and password. We would never know that.
Okay.
I was just demoing to you my router. I know the password. Now, in a case of wireless ISPs that manage routers and they have access, then yes, they do know the password for the routers.
Okay. So that means the app that you initiated is only working from your home, and then you, I don't know. So the device your daughter have in your home is in the subnet, right?
I know, and we're running just shortly out of time. I know here.
Okay.
I'll be available. You also have our email. I'm not sure that I'm fully comprehending the question. Just send me the email and I'll reply to it.
I have one more question. So on your
Okay.
Yeah, I'll be right back also, so grab me.
Yeah.
I'll have to talk to you.
Just real briefly, is it limited just to the gateway, or do you have plans to move, like if we're building full infrastructures, I work in large homes, so I want to be able to push configuration to all my APs or anything like that. Is there any plans to go beyond?
I don't know if you noticed when I was at the dashboard, you could set up a smart router or a smart bridge. And you can also set up a smart bridge WAN. So if you're using the MikroTik as a demarcation point in front of the user router, we also have that mode too. So SBW, SB, and SR. Yeah.
I was just wondering if you can tell us what the overhead is on this, the bandwidth overhead, and is it always transmitting data to the cloud, or?
Sure. I mean, do you want to answer that?
Yeah, so the bandwidth overhead is really minimal. I have my estimate is about like less than 100 kilobit per second in peak time when we are capturing like a snapshot of the network, and that's it. So, and that's the peak I've ever seen. So usually like 10K, 20K, that's what we see. Because we are not in line to the traffic. We are sitting on the cloud and just getting the snapshot of the traffic.
Have you had much success with deploying it in businesses for managing business access wireless?
This is being deployed to very small businesses, wineries, so like 8, 15 people. I don't know if that's what you're referring to. Our goal is to be the missing IT person. When you scale to 50 or 150 people, usually there's already the IT person that can be the smart network for you. But for the winery with 15 people and no IT, smart network will become your IT.
Okay.
Just the clarification on your roadmap, I didn't hear if you planned on releasing this as a standalone product to an end user, like just me at home, because I'd like to deploy this all over the place.
Right. So let me reiterate. In November, we will launch it on smartrouter.com. You will be able to buy a router from us that is pre-configured, or download the app and do it yourself, bring your own router. This works on any MikroTik router. You can just take any MikroTik router. I mean, this is router, literally the only thing I did on it is secure it and add the LT. Otherwise, it's default settings. At what point? No. We're not involved.
Any more questions? Okay, thank you.
Thank you.